This video is the Spring Final Review Day 3 Part 2, so this is pages 4 through 6. If you're looking for pages 1 through 3, it was the other video. So with this, we're finishing up logs. My axis is always the opposite of what's inside with x, the same as what follows. So -5, 2. My asymptote is at -5 because logs are vertical. My domain will be everything greater than -5. And range is all reals. This one has a base of 4, so that means that it's increasing, so I start low and go high. And remember that you can plug this expression into y equals at the beginning or after you've graphed it to make sure you graph it correctly. You can do the same thing on problem 23 with the graphing and y equals. We want to put in a fraction and we type exactly what we see. So we have 3 on the top, x minus 2 on the bottom, and then a +1 on the outside. We graph it and we can see kind of what's going on here. It's easier if you start with your vertical asymptote. Vertical is a vux, so x equals, and horizontal is a hoi, so y equals. X equals the opposite of whatever's normally with x. Y equals the same as what follows. We do not use this 3 for anything in our vertical or horizontal asymptotes. My domain is very simply whatever my vertical asymptote can't be, and my range is the same. So I'm writing the exact same things but with a slash through them. If you draw your asymptotes, this will help you a lot more. So vertical asymptote at x is 2, horizontal when y is 1. The only thing we use the top number for is positive or negative. This is positive, so my my graph is going to be in the top right, and then in the bottom left. We always go in opposite corners. So if it's positive, it's top right. If it's negative, it's top left. And then the opposite corner. 24 vertical is x equals the opposite of what's with x. So domain can't be where my vertical asymptote is. Horizontal is whatever follows. And my range can't be whatever follows. So x is -3. I go to -3, draw a vertical asymptote. Y is -5. I go to -5 and draw a horizontal asymptote. My top number is positive, so this will be in the top right and the bottom left. These are just asking me for vertical, horizontal, domain, and range. So vertical, again, is the opposite of whatever is right next to x, and domain is not that. Horizontal is whatever follows. Range is not that. 26, vertical is at 5, so domain can't be 5. Horizontal is at -7, so range can't be -7. Excuse me. 27, vertical is at 2, so domain can't be 2. Horizontal is at 5, so range can't be 5. Vertical is at -4, so domain can't be -4. Horizontal is at 4, so range can't be 4. And again, notice I'm not putting these top numbers anywhere in my problem. The last part is about trend lines and scatter plots, so the things we just took our test over. Part A says, what was the ticket price at a movie theater or ticket sales when the price per ticket was $6.50? So $6.50 price per ticket is right here. I follow it up till I get to the dot. The dot is at 6,000 in ticket sales. Always, always, always make sure you read the scales because there's some problems on your final where the scales are a little bit tricky. When the sales were 8,000, what was the price per ticket? So 8,000, I follow along till I get a dot. That dot is at 4 per ticket. And this is just in dollars, not in thousands. Draw a trend line. So I'm going to erase everything I've drawn so far so I can see my trend line. And predict when the price per ticket is $9. So $9 would be about $3 25 maybe, a little bit above 3. What type of correlation? Well, we drew a negative line, so this has a negative correlation. My scatter plot is going down. And as the price per ticket increases, what happens to the ticket sales? My sales decrease. Problem 30, they want me to make a scatter plot of the data. So 70, these are even numbers in between. Okay, wait a second. 64, 66, 68, 70, 72, 74, 76, 78, and 80. My scale's a little off. So 71 and 170, 68 and 160, 70 and 175, 73 and 180, 74 and 190. Draw a trend line. As the height of the basketball player increases, weight increases. The weight of a 6-foot-tall basketball player, 6 feet tall, is 72 inches, because 6 times 12. So 72 would be maybe about 180. And if a basketball player weighs 185, they're probably, well, I think my scale's off again. So let's just go with like 75 inches. Okay, this one, because I'm talking real world data and they don't give me a graph, I'm going to graph this in my calculator. So remember, your steps are to start in stat edit. And type it in exactly like I see it. Once I've done that, I'm going to click second, y equals, enter to turn my stat plot on, and then zoom 9 to look at my data. This appears to follow a linear relationship, so I'm going to circle linear. And then because it's linear, I'm going to run StatCalc 4. You can see my R squared is on and it's not perfect, but I've already looked at my data and know that it's linear. So I'm going to round to like 18.5x minus 1081.8. And then using this part B, predict when the temperature is 90. So I can plug this in to y equals, go second table and skip down to 90. Or I can just type it in and replace x with 90. In this case, it's probably faster to do that because it takes a while to scroll. But you can also plug that in and it's easier on certain things, especially if you have quadratics. So my prediction for the monies made would be $5.83 and 20 cents.